Alright, in this video I'm going to show you how to solve exponential equations, and then I'll do a second video and I'll solve logarithmic equations. So let's go ahead and get started. So let's start with exponential equations, and I want to show you a property. If you have b to the m power equal to b to the n power, then m must equal n. And it actually goes both ways. Basically what we're saying here is if you have two powers of the same base and those two expressions are equal, the exponents must be equal. So we'll see how this works with some examples. So 4 to the x power equals 64. Of course we should know what x is here. This is going to be 3. However, using this idea, we could write 64 with the base of 4. So let's do that. This is 4 to the x equals 4 cubed. And so the only way this could be equal, since the bases are equal, the exponents must be equal. So x would equal 3. Now in this problem we really didn't need to do that because we could do that problem in our head. But as we go further along, you'll see how we can use this and it'll be helpful. So on number 2 you have 3 to the 2x plus 1 power is equal to 27. So notice we could write 27 as a power of 3. It would be 3 cubed. So let's go ahead and do that. So now we have the same bases. So the only way these two powers of 3 could be equal is if the exponents are equal. So let's go ahead and set those equal. We'll subtract 1 on both sides. We get 2x equals 2. And so we're going to get x equals 1. Now these are super easy to check. Let's go ahead and plug in 1 into this. So 3 to the 2 times 1, or 2 plus 1, that would be 3 cubed equals 27, which of course is true. Alright, let's look at number 3. 5 to the 2 minus x power equals 1 over 125. So you've got, we discussed this before, you've got to know your exponents pretty well here. I know that 5 cubed is 125. So we know that negative exponents lead to reciprocals. In fact, 5 to the negative 3 power would be 1 over 125. So let's rewrite this, and on the right side we'll write that as 5 to the negative 3 power. Now we have the same basis, so we can set our exponents equal. We get 2 minus x equals negative 3. Let's go ahead and subtract 2 on both sides. We'll get minus x is equal to negative 5. And so we're going to get x equals 5 here. And again, this is very easy to check. I'll go ahead and put in the 5 for x. And 2 minus 5 is negative 3. So 5 to the negative 3 power is equal to 1 over 125. And again, that's true. And again, we've talked about this before. You've got to get to know your powers and be able to handle things like negative exponents. And so you could actually go back and look at my lesson on an introduction to logarithms if you need to do that. Let's move on. So there's two methods that we're going to use when we solve exponential equations. And this technique is what I call, in short, I just say equal bases. So we just want to get our bases equal so that we can set our exponents equal. That's what we're doing here. So I'm calling this method the equal bases method. So we're going to use this for a couple more problems. Now if you look at 4 to the x power equals 32, we can't write 32 as a power of 4. See, 4 squared is 16, and 4 cubed is 64. So we skip 32. So what are we going to do here? So again, there isn't any power of 4, not any nice power that equals 32. So let's think smaller. 4 is actually a power of 2. What about 32? In other words, 2 could be our base. So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, now we're getting somewhere. 2 to the 5th power is 32, so we can actually write 4 as 2 squared, and 32 as 2 to the 5th, and that's going to help us to get our bases equal. So it would be 2 squared, or 4 to the x power, and then on the other side 2 to the 5th power. We're going to get 2 to the 2x power is equal to 2 to the 5th power. So we'll go ahead and set our, now that our bases are equal, we can set our exponents equal, and we're going to get 5/2. Let's move on. Now you could check that problem, and you'll find that it does work. Probably the easiest way is just to take 4 to the 5/2 power on your calculator. Let's go ahead and look at number 5. So actually this is very similar to the one we just did. I can't write 8 as some power of 4. So I've got to think smaller again. I'll have to use 2. In fact, 2 cubed is 8. So we'll write the left side is 2 cubed to the 1 minus x power. And of course 4 can be written as a power of 2. It's 2 squared to the x plus 2 power. So now we have a power to a power. In a case like that, we multiplied the two numbers. Now be careful, we're multiplying 3 times 1 minus x. So we have to put the 1 minus x in parentheses and distribute the 3. So this will be, let's go ahead and do that step. So we do have to distribute here. We get 2 to the 3 minus 3x power is equal to the 2x plus 4 power. Again, we're just distributing there. So now our bases are equal. Let's go ahead and set our exponents equal. I need to get x on one side only, so let's subtract 2x on both sides. To get x by itself, let's get rid of that 3 first. We get negative 5x is equal to 1. And let's divide by negative 5. And we'll get x is equal to negative 1/5. And again, you can try using your calculator to do this. The numbers aren't going to be real nice to work with here, so it's just easiest to use your calculator. All right, number 6. So far, we've been getting our bases to be equal and then setting our exponents equal. Well, we can't write 8 as 10 to some power. That just is not going to happen. So we got to come up with something different. Now, if you think about it, there's not really a whole lot we can do here, but we're trying to solve for x, which is in the exponent. And we've been in this situation before. In order to solve for x, when we have a variable in the exponent, we're going to have to switch forms. So let's do that. So it's going to be log. Actually, again, I'll review. We've been doing equal bases, the technique of equal bases, getting our bases equal and then setting the exponents equal. So here we're just going to change forms. And so these are the only two approaches that we're going to use with exponential equations. So here we can write this as a log. It's going to be the log base 10 of 8.07 equals x. And we don't normally write the 10 here. I'm going to also put x on the other side. So you can actually put this into your calculator using your LOG button on the front of your calculator, and you get 0.9069. The nice thing about these kind of problems is they're super easy to check. So we're going to take 10 to that power and see if it's 8.07. In fact, one of the reasons why we normally get 4 decimal accuracy is because when we check it, we want it to be pretty accurate. And if you plug that into your calculator, you should see that it's pretty close to 8.07. There is just a little bit of rounding error. All right, let's move on to the next problem. So e to the x equals 0.83 or 83 hundredths. So we're going to have to change this to log form as well. It's going to be base e log. Again, I've shown you this before. We can, to check ourselves, we know that e to the x power is equal to that number, and that's what we have up above, so we're good. Alright, so we don't normally write a log that's base e this way. We're going to want to rewrite this using the ln. Remember, natural log, that's what a log base e is. So this becomes the natural log of 0.83, and you throw that in your calculator and you should get negative 0.1863. Again, very easy to check this. You can verify that for yourself. If you put that into your calculator, it does work. All right, let's look at number 8. So same kind of problem. You need to change this to logarithmic form. So go ahead and do that if you haven't already. All right, let's see how you did. So it's the log, the base is 19. Remember, the exponent goes all by itself, and the 143 goes right there. And so it's a log base 19 of 143. So this is a base other than base 10 or base e. And so this is the kind of problem where we had to use the change of base formula. And we usually would change our bases to base 10 logs, although you could also use natural logs. So let's go ahead and do that. It's going to be the log of 143 over the log of 19. Notice I put the parentheses in there. You should do that when you enter these into your calculator. And when you do that, you get about 1.6855. Again, this is very easy to check. Just go ahead and plug it in. And when you put that into your calculator, you should find that it works. All right, let's move on to the next problem. So it's similar to what we've done before, but we've got an extra number here, this 9. So the e is my base, the x is my exponent, and the 107 is my answer. So I've got an extra number in there. I have more than just the 3 parts that we look for when we're in exponential form. So what we need to do is get rid of that 9. Well, it's 9 times e to the x. So we can do the opposite and divide each side by 9 to get rid of that 9. So when we do that, we get e to the x equals 107 over 9. Let's change this to log form. You may want to stop the video and try it and then see how you did. So it's log base e of 107 over 9 equals x, which we write as the natural log of 107 over 9. Now, if you were to change that to a decimal, you'd want to carry at least 3 or 4 decimal places. Otherwise, it's going to throw your answer off a little bit. So when you put that into your calculator, you should get 2.4756. And if you plug that in to the original equation, you can verify that that does equal 107. All right, let's move on. So this is actually a very similar problem. You might want to stop the video and do the problem and then see how you did. So you should have divided by 1,000 first. You get e to the minus 4x equals 0.075. And now we have the 3 parts, base, exponent, answer. Let's go ahead and write this in log form. Again, this is going to be written as a natural log. Log base e is natural log. And then we've not quite got x by itself. Notice I also switched sides. It doesn't matter which side you put them on, just make sure they look the same. I just changed log base e to natural log. And now we need to divide by -4 on each side so that x is by itself. When you put that into your calculator, you should get 0.6476. And again, you can verify that by plugging it into your calculator, and you should get 75. All right, one last problem. Again, it's really a problem like what we've just done. Actually, I'm sorry, it's not the last one. I think we have one more after this. We'll see. So again, if you want, you can stop the video and try this one and then look at the video. All right, so you're going to get the log base 5 of 137 equals x minus 3. Now, the left side is a base 5 log, so we're going to need the change of base rule. By the way, I did talk about how some of you may have the TI-84 calculator, and if you have a newer version, if you look under the math menu in the first column, there's a feature called log base or log B or something like that, and you can actually use that to find the value of log base 5 of 137. But otherwise, you're going to have to use the change of base formula, which we're going to get a log of 137 over the log of 5. Again, notice now the base is 10. And then let's add 3 to both sides. So now the challenge is to just make sure that you can evaluate that using your calculator. So try plugging that into your calculator and see what you get. You ought to get 6.0570. And again, you can check that on your calculator, and you should find that that does equal 137. And that is the end.